In this example, we want to verify that the function satisfies the two hypotheses of the mean value theorem on the closed interval from 4 to 8. And if it does, then we want to find those numbers, those C values. So remember, there are two hypotheses for the mean value theorem. The first is that the function must be continuous on the closed interval from A to B, and the second is the function must be differentiable on the open interval from A to B. So we have to discuss both of these and verify and prove that this function is both continuous as well as differentiable. Let's start with continuity. We know that the function that we were given, this is a root function, specifically a square root function, and the parent function is the square root of x. The -4, remember, all that's doing is shifting the graph to the right 4. So we know from our prior experience with square root functions that they are definitely continuous over their domains. So we just need to determine the domain of this particular function. Remember, we cannot have a negative inside of a square root, but 0 is certainly fine. So we need that x minus 4 to be greater than or equal to 0. In other words, x must be greater than or equal to 4. So our domain is all x values from 4 to infinity, including 4. It's fine to put 4 into this function. Remember, 4 minus 4 is 0. So we can see that this function is going to be continuous on the closed interval from 4 to infinity, which that is great because we needed it to be continuous from 4 to 8, which it is. Then let's move on to differentiability. And we can do this two different ways. We can sort of think about a graph, since we should know what the square root graph looks like. And since this is just a square root graph shifted to the right 4 units, then you should have a kind of mental image, without using technology to help you too much here, that the graph looks something like this. And remember, there's an issue at this initial point on the square root functions. We know that if we took a look at the tangent line at that initial point, the tangent line would be vertical, and vertical lines have an undefined slope. So there's no derivative then at that initial point. In this case, that initial point is at 4. So no derivative is going to exist at 4. And we could verify that with a little bit of algebra if we went ahead and actually found the derivative, which we're going to need to do anyway later. So we might as well do it now. So we may want to rewrite this function. Remember, the square root is also, or can be rewritten as x minus 4 to the 1/2 power. So by doing my power rule and my chain rule, my derivative would then be 1/2 times the quantity x minus 4 to the negative 1/2 power. And chain rule, I'd be chaining on the derivative of x minus 4, which would just be a 1. So with a quick rewrite, we know that this would be 1 divided by 2 times the square root of x minus 4. So looking at the derivative, you can see here that x cannot equal 4 in the derivative, because then I would have division by 0, and that's undefined. So we can see that this algebraic analysis verifies what we thought from the graph, that there would be no derivative at 4, so the function is not differentiable at 4. But that's okay, because remember that differentiability only had to be on the open interval. So it's okay that it's not differentiable at 4, because it's differentiable on the open interval, basically, from 4 to 8. So that's our analysis. Now we just need to write a sentence basically summarizing everything that we just discovered. So here's a good summary. F of x is a root function. You could also say square root function. So it is continuous on its domain, the closed interval 4 to infinity, and it is differentiable on the open interval from 4 to infinity. Therefore, the mean value theorem applies. Now we can go to work to actually find that value of C. So the rest of our work is really going to be algebraic. Going back to what the mean value theorem actually states, the conclusion, it's saying that somewhere the value of the derivative must be equal to the value of the average rate of change. And again, let me say that a different way. Remember that value of that derivative, we're thinking that somewhere the slope of the tangent line must be equal to the slope of the secant line. or the instantaneous rate of change is equal to the average rate of change. So we need to find the slope of the secant line from 4 to 8. So again, I'm just trying to review everything you know right now about the slope of the secant line. It's the average rate of change from 4 to 8. So that's just going to be the slope. So we're going to go f of 8 minus f of 4, all divided by 8 minus 4. So we're using the original function, the f of x is equal to the square root, I'll write it over here for reference, square root of x minus 4. So if we plug 8 into this function, 8 minus 4 is 4, and the square root of 4 is going to be 2. If we plug 4 in, 4 minus 4 is 0, square root of 0 is 0. So we're going to have 2 minus 0 divided by 8 minus 4, or 2 divided by 4. So the slope of that secant line is 1/2. And the mean value theorem says then somewhere the slope of the tangent line must be 1/2. So the slope of the tangent line, we've actually already done that work. I'm just going to go ahead and recap it here. That's my instantaneous rate of change. That's going to be my derivative, which we already found. And we found that the derivative was 1 divided by 2 times the square root of x minus 4. I'm going to go ahead and take that simplified version here. So now we're just needing to set these two equal to one another. So somewhere the derivative, 1 over 2 times the square root of x minus 4, that needs to equal 1/2. And we solve. I'm going to solve by just cross multiplying. So basically going, okay, 1 times 2 is equal to 1 times 2 times the square root. So that'll be 2 is equal to 2 times the square root of x minus 4. Dividing both sides by 2, 1 is equal to the square root of x minus 4. Then we'll square both sides. So 1 equals x minus 4. And adding 4 gives x is equal to 5. So this is our c value. This is between 4 and 8, remember? And this is the place where the slope of the secant line is equal to the slope of the tangent line. So I always like to wrap it all together with a picture because so many of us are visual. So a visual will really help. So we know we have our square root function that looks something like this. Initial point is at 4. So we were looking from 4 to 8. So looking at the slope of the secant line here, this is my secant line going from 4 to 8. We found that the slope of that line was 1/2. 1/2. And then we found that at 5, that was the x value, where the slope of the tangent line is also 1/2. So imagine these parallel lines. Here's my tangent line, and it should also have a slope of 1/2 when x is equal to 5. That is our c value, our value of c, where the average rate of change is equal to the instantaneous rate of change.